My good friend Ben has been painting some straight lines on the field, as opposed to wavy, I guess. Makes sense. I haven't played rugby in a while, I'll admit. Oh, it's for training exercises. Okay, that's all right. So I don't need to be perfect. It's not for the game. So we're given these straight lines here. The ones in black. It's all right. There's a rectangle, and then there's a line that goes about down the middle. We're told that the total length of all the painted lines is 20 meters. So that's adding up. So it's like you walk along all these black lines, and then you add on this bit in the middle, you would have walked 20 meters. We're also given that the area of this shaded rectangle is 14 meters squared. Our task is to find possible values for x. So this type of problem is great for us because it boils down to algebra, right? We have some context. That the hardest step is the first step, which is putting it into some equations, an equation or multiple equations. And then from there, all we're doing is using everything we know about solving equations to solve for x. So the two bits of information that we can use to form our equations are those second and third lines there. And the problem has kindly given us x and y. Right, there are variables. If they didn't, then it's a bit harder. Then you actually just need to say, all right, let's let this length be x and this be y. But they've pointed us in the right direction. Thank you, NCEA. So let's tackle this first equation. The total length of all the painted lines is 20 meters. Okay, so it must equal 20, all the painted lines. Now, in terms of x and y, what is that? So we have 1x goes left to right. We have another one and another one. Right, we have 3 lots of x. We have 1y, 2y. We have 2 lots of y. And together, that distance of 3x and 2y will equal this 20. Let me just write it on the right-hand side. Doesn't matter, but I like the look of that more. Maths is an art form too. You're free to express yourself with which side of the equation you put your 20. Now, equation 2. The shaded area is 14. Okay. The area is the area of a rectangle, and we know that is length times width, or in this case, x times y is equal to 14. So what we've done is we've taken information from the question and written 2 equations in terms of x and y. That was the hard bit. Now, the easier bit is just solving it. So looking at this, we have 2 equations. So we could, when we're doing simultaneous equations, one technique is to subtract equations from each other. However, this is not linear because we have x times y. So we can't do that. But what we can do is rearrange one of the equations. For example, this one. Let's say rearrange it for y. So y would equal 14 divided by x. Right, so I haven't changed the equation. It still means the same thing, but I just rearranged it for y. Divided both sides by x. And now we can take this y, which is actually 14 over x, and substitute it in for y in the first equation. So that first equation, so we say substitute equation 2 into equation 1. Gives us 3x plus 2y. Now we said y is equal to 14 over x. And the whole thing is equal to 20. Okay, so that's called substitution. Now we can simplify it a bit. So 3x, 2 times 14 over x is the same as 28 over x is equal to 20. Now, I don't like that x in the denominator. Sorry, x in the denominator. It's nothing personal. But it'll be a lot easier if we had no fractions to solve for x. So what we can do now is multiply both sides of the equation by x. So we'd get 3x squared. Now what's 28 divided by x times x? That's just 28. And then 20 becomes 20x. Okay, this is looking a bit more familiar. Now we can subtract 20x from both sides. And that gives us our standard form of a quadratic. All right, so when we get to here, this is great. We are in super familiar territory. We have a quadratic equation. We can now factorize and then solve for x. So to factorize, we have our two sets of brackets. The coefficient of x squared is 3. So one of the x terms will need to be 3x in order to expand it out to get back to 3x squared. The two numbers need to multiply to 28. To negative 28, excuse me. No. Start that again. Two numbers we need to find multiply to positive 28. However, they won't need to add to negative 20, but 3x times that number plus that number times x will need to add to negative 20. Which makes me think we want two negative numbers. Right, so 28 factors could be, well, let's start simple. 1, 28, or negative 1, negative 28. 2, 14, or negative 2, negative 14. 4, 7, or negative 4, negative 7. Quite a few factors. You might be here a while trying them all, but that's fine. What else do you have to do other than maths? So let's just have a think what could make sense. 1 and 28, if that was 28, 3x times 28 is too high of a number. So we can eliminate those two. Which narrows it down. We need this to be negative, so it can't be either of those positive options. And so we're left with two options. So let's try negative 2 and negative 14. So we could put it like this. Well, that'll be negative 42x. That's too big. What if we swapped these two numbers? Right, it does change depending on the order. So 3x times negative 2 is negative 6x minus 14x. Indeed, that adds to minus 20x. So we found our solution. But when you do get here, do just take your time to expand it out and check. Right, for example, 3x squared minus 6x minus 14x plus 28 is the same as that. But now that we've factorized it, we can solve. So 3x minus 14 equals 0, or x minus 2 equals 0. So on the first equation, we could add 14 to both sides, then divide both sides by 3 to get x equals 14 over 3. In the other equation, we could add 2 to both sides to get x equals 2. Whew. A lot of steps, but again, it's just algebra. When we get after we put them into the equations at the top here, it's just algebra, crunching your algebra. And hopefully you got something from this little bit here where even though we had 6 possibilities plus their flipped numbers, right, like the order, so 12, we were able to eliminate 4 just with a bit of common sense. We tried one, it didn't work, but then we flipped it and it did, which let us factorize that quadratic equation to then find the solution for x.